Since retiring, he has volunteered for many climate organizations. He heads up the Climate Action Plan team for the United States League of Women Voters Climate Interest Group and heads the local League of Women Voters Climate Change team. He currently leads the Climate Reality Project's South Central Coast chapter and a local group that specializes in the city of Ventura called the Ventura Climate Coalition. Wayne is a co-host of the Ask Sean show, which is a YouTube show that offers help to homeowners who want to electrify their home. Being an electrical engineer, he is passionate about electrification and has converted his home to all electric. Take it away, Wayne.
Okay, thank you. So today, or this month, is Earth Month. In January of 1969, an oil platform off the coast of Santa Barbara blew out more than 3 million gallons of oil into the ocean, killing thousands of seabirds, dolphins, seals, and other sea life. People organized to protect the environment through education and regulation, and the first Earth Day was celebrated on April 22nd, 1970. Earth Day has continued to be celebrated to remind people that the Earth is our home and we must take care of it. So I celebrate the Earth. I celebrate the Earth first off because the Earth is filled with beauty and life, like the Grand Canyon or Yosemite or Antelope Canyon in Arizona. The Earth is unique in the universe. I'd like to share some of the interesting astronomical characteristics of the Earth. This is the Milky Way, our galaxy. It's 100,000 light years across. That means it takes light 100,000 years to go across this Milky Way. It's estimated to have 100 billion stars, and it has a black hole in the center of it. And we are located on one of the spiral arms, about 26,000 light years from the center. This shows the inner planets of our solar system. The orbits are to scale, but the planets and the sun certainly aren't. The Earth is at a very good distance to have the temperature necessary for life. The range of distances from a star to a planet that can have the temperature to have liquid water is called the Goldilocks zone. And we are obviously in that Goldilocks zone. The drawing on the left shows the eccentricity of the Earth's orbit. The eccentricity cycles from 1% to 13% over a span of about 100,000 years. Note that this drawing is much exaggerated. The eccentricity is presently about 3.4%, and it is getting smaller or more circular. The center shows the obliquity or the tilt of the Earth. That tilt gives us our seasons. You know, as the North Pole tilts towards the sun, it's summer in the Northern Hemisphere. The tilt varies a little bit over a 41,000 year cycle. If the tilt is greater, the seasons are longer and the summers are hotter and the winters are colder. Currently, we're about in the middle with a tilt of about 23.4 degrees. Precession. Precession is the rotation of the Earth on its axis. It rotates around in a clockwise direction from the north. So this cycle takes 26,000 years. So what this effectively does is it changes the orientation with respect to the eccentricity of the orbit. So right now, we're summer right now, but in about what, 6,000 years will be more like spring. And then in 13,000 years, it'll be winter because the axis is moving. So, uh, those are the three main motions. So the eccentricity also causes the winter and summer seasons to vary in length. At present, the eccentricity makes the northern hemisphere summer 4.5 days longer than its winter. That's because the summer is on the uh, aphelion, which is the furthest uh, away from the sun. So it takes longer. The further away you are from the sun, the orbit slows down a bit. And when it gets closer, it speeds up. So right now, our summers are a little bit longer than our winters. Now, in 1920, the astronomer Milutin Milankovic theorized that these motions together could strongly influence the Earth's climate patterns. These cycles have then become known as the Milankovitch cycles. So the top two plots are temperature data derived from bases in Antarctica. The first one is the European project for ice coring in the Antarctic. And the Vostok Station is also located in Antarctica. And the bottom is what they believe is the core thickness that has been derived from multiple sources. So you can see what these eccentricity and precession have done and tilt have done with our climate. You can see there's about 100,000 year cycle. And it should be noted that during this plot, the carbon dioxide was quite stable. So the resulting temperature differences are primarily from the Milankovitch cycles. Next up, our neighbor, the moon. Here's a photo of the moon from the Artemis spaceship. Some 100 million years after the solar system formed, the moon joined us. The moon has significant influence on the Earth, and here are some of the characteristics. The moon revolves around the Earth about once every 29 days, and the moon's gravitational field influences the tides. The moon's orbit is tilted with respect to the Earth's orbital plane. And here in this drawing, it shows that a little bit with regards to eclipses. So eclipses will occur during new moons when the moon is between the sun and the Earth. So this is a new moon, that's a new moon, that's a new moon, and that's a new moon. But because the orbit of the moon is tilted, we don't have eclipses every month. So we only have eclipses when the orbit is such that it's pretty much in line with the orbit of the orbital plane of the Earth. So very coincidentally, from the Earth, as you view from the Earth, the apparent size of the moon and the sun are very close. In fact, the eccentricities of the orbits can make the sun appear smaller or larger than the moon. This gives us great solar eclipses. So this is a picture of a total solar eclipse where the apparent size of the moon is just greater than that of the sun. And the fact that it's just a little bit, the moon is just a little bit apparently larger, you get to see some really close up of things on the sun that if the moon were larger, you wouldn't see. So these are prominences, solar flares from the moon. I mean, from the sun, sorry. So this is a view that's zoomed out. You can see the white corona. This corona is up to about 1,000,000 degrees centigrade. If you're witnessing a solar eclipse, the ground around you looks eerily white because it's super white because of the super white corona. And this is what an annual eclipse looks like. This is when the apparent size of the moon is less than the apparent size of the sun. And this is a drawing of the Earth and the moon to scale. You can see how far off it looks, there's quite a bit of distance there. Now, if we extend this drawing to include the sun and assume the Earth is 1 inch in diameter, the moon would be a 1/4 inch in diameter and 30 inches away, and the sun would be 9 foot 1 inch in diameter and about 960 feet away. Well, let's get back to Earth now and take a look at the Earth's surface. So although the Earth is sometimes called the third rock from the sun, it isn't solid. The Earth's surface is basically pieces of crust or plates that are floating on hot liquid magma. This image shows those plates. In California, we live on the boundary of the Pacific Plate and the North American Plate. And as a result, we get a lot of earthquakes. Movement of the plates form mountains, and of course, volcanoes form mountains also. I have thought if we didn't have plate tectonics, the Earth would be covered with water, and therefore we would be fish. So this is an animation of the plates as they're moving, and that's millions of years ago. So I'll do that one more time here. So it's 250 million years, and we're counting down, so you can see how much the plates have actually moved over that time span. But a million years, it's really hard to imagine a million years, and it hardly moved in a million years. So our world is changing. Some plates are spreading apart, like in the mid-Atlantic, and they're being abducted, like over in the California coast. Let's take a look at the Earth's atmosphere. Here's a picture of the Earth from the International Space Station. The sun is just peeking over the horizon. You can see some of the different layers of the atmosphere. The troposphere is the lowest layer, and that's where we live. It's about 60,000 feet thick, which is a bit more than 11 miles. So compare that to the diameter of the Earth, which is just shy of 8,000 miles. But if you look at the atmosphere as thin as it is, the surface, if we didn't have the atmosphere, the surface might look like the moon again. So our atmosphere protects us from small meteors. It also plays a part in erosion, which erases some of those pockmarks caused by meteors. Here's a meteor. This is the meteor crater in Arizona. It was formed by the impact of a crater about 150 foot in diameter, and it hit the Earth going at about 45,000 miles an hour. The energy it released was that of about 10 megatons of TNT. Over time, this crater will be rendered unrecognizable by the erosion of water and wind. So back to the atmosphere. The atmosphere also blocks UV radiation and solar wind, which consists of charged particles. The solar wind gives us auroras. The bulk of the atmosphere is below 60,000 feet, but it continues up beyond 60 miles. But there, of course, it's very thin. And here's a fun fact. If you could convert the atmosphere into a liquid, it would be about 36 foot deep. Another thing about the atmosphere, without it, we wouldn't have sound. Now we're going to get into a little of the history of the Earth. So this is a cute representation of the Earth's geologic eras. Note that the bottom is when the Earth was created some 4.6 billion years ago. And note that the time scale on the right is not linear. So between 20 million and 100 million years ago, after the formation of the solar system, the moon became Earth's satellite. Life appeared in the Archean period, some 2.5 billion years ago. During this time, bacteria released oxygen into the atmosphere, and this became known as the Great Oxygenation Event. Next, I'd like to point out the Permian-Triassic Extinction event, or the PT event, which occurred about 250 million years ago. Within a span of about just a million years, over 90% of the Earth's marine organisms became extinct, along with more than 70% of all terrestrial life. The scientific consensus is that the main cause of the extinction was volcanic eruptions that released sulfur dioxide and carbon dioxide, resulting in elevated global temperatures, and the ocean became ocean-starved and acidified. The Cretaceous Tertiary event occurred about 66 million years ago after a great asteroid struck the Earth. The asteroid was about 8 miles in diameter and was traveling at 30,000 miles per hour. It created a 100-mile wide crater that lies beneath the waters of the Yucatan Peninsula. Roughly 80% of all species died because of this event, including all the dinosaurs. With the dinosaurs gone, the smaller mammals that survived started to become established. Some of those mammals were precursors to humans. The last glacial period started about 115,000 years ago and ended about 12,000 years ago. During that time, vast ice sheets covered North America and Eurasia. Global temperatures were about 10 degrees Fahrenheit colder than they are today. During this period, woolly mammoths, saber-toothed tigers, and American camels roamed the North Americas, but they went extinct at the end of the period. Scientists believe that their extinction could be due to the change in climate, which reduced their food stock and habitat, or by hunting by man, or both. And here's that chart again of the temperature covering the last glacial period. This arrow indicates the beginning of the last glacial period, and that one indicates the end. As we saw earlier, the Milankovitch cycles is the main driver of these temperature changes. The Holocene is also called the Anthropocene. It's the age of man. The first proto-humans emerged a little more than 2 million years ago. During the past 200,000 years ago, we've seen modern humans walk the Earth. The Holocene period began after the last glacial period when man progressed far enough with technical and social organization. During the Holocene, the environment has allowed humans to thrive. It's worthy of celebration. The Holocene weather enabled agriculture. Having a secure food supply gave people more free time to invent and explore. Slow, steady progress was being made, but the Industrial Revolution really supercharged things. Innovation accelerated in the Industrial Revolution. One invention was the seed drill developed by Jethro Tull around 1701. As an aside, the Ian Anderson band, Jethro Tull, was named after him by the band's booking manager, who happened to be a history buff. The seed drill uses screws to meter out seed and it plants them in multiple rows at a time. Together with crop rotation and new varieties of crops, this led to more productive farming. This enabled population growth. So England found itself running out of wood for fuel, and it transitioned to using coal at the end of the 16th century. As coal mining grew, removing water from coal mines became a big issue. The first steam engines were invented primarily to power pumps to pump water from mines. This is one of the early steam engines, rather large, isn't it? Improvements in steam engines continued, though, as they were used more and more to pump water from mines. Also in England, technology was boosting another industry, textiles. Before the Industrial Revolution, yarn was spun by individuals spread throughout the country using spinning wheels. High demand for thread led to the invention of the spinning jenny in 1764 by James Hargreaves. It could spin multiple spools at the same time. By the time Hargreaves died 14 years later, there were more than 20,000 spinning jennies in Britain. Just 5 years after the spinning jenny was patented, another spinning technology, the water frame, was patented. It further increased the production of yarn and thread by employing water power. Now, this one's a small one. I'm sure they were much bigger than this. But 10 years after that, in 1779, the spinning mule was invented. Spinning mules could make cotton thread much quicker and at huge volumes, hundreds of spools at a time. The first ones were water powered, but as steam engines improved, they were used in the textile mills. So the mills no longer needed to be located on rivers, but they still needed a supply of water for the steam engines. So they were located near rivers or canals. And around this time, steam locomotives were starting to be used for transporting goods. With all this coal being burned, some scientists began to wonder if it would have an effect on the environment. And one scientist who was thinking about this was Joseph Fourier. Fourier is famous for his work in mathematics and heat transfer. In the 1820s, Fourier calculated that the Earth, with its distance from the sun, should be considerably cooler than it is. He examined various possible reasons, but he could never come up with a satisfactory explanation. Enter Eunice Foote. She was not only a scientist, but she, interestingly, was also active in the women's right to vote movement. In fact, she was a dear friend and neighbor of the well-known suffragette Elizabeth Cady Stanton. In 1856, she published the results of an experiment which involved putting various gases in jars and seeing how the gases heated when exposed to the sun and how they cooled in the shade. She noted that carbon dioxide became hotter and stayed hotter longer. She hypothesized that adding carbon dioxide to the atmosphere would warm it. Savant Arrhenius was a mathematician and a Nobel Prize-winning chemist. In 1896, he calculated that if the CO2 level doubled from the values in his time, which was the late 1800s, the temperature of the Earth would increase by 9 to 11 degrees Fahrenheit. Recent calculations are a bit less than that, but he was on the right track. So he and Eunice Foote recognized the planet warming properties of carbon dioxide. So what is a greenhouse gas? We need to know a little bit about thermal radiation to answer that question. Matter that is above the absolute zero temperature radiates electromagnetic radiation known as thermal radiation. It can be thought of as very deep infrared. You experience thermal radiation when you're near a fire. You can feel the heat at a distance. Here's an example of thermal radiation from a person. He's radiating infrared and a thermal camera picks it up. So what makes a gas a greenhouse gas? On the left are nitrogen and oxygen. Nitrogen makes up 78% of the atmosphere and oxygen 21%. These are not greenhouse gases, and that's a good thing. Nitrogen and oxygen aren't greenhouse gases because they're symmetrical and they only have a single type of element. Their chemical bonds are symmetrical and they're not influenced by the thermal electromagnetic radiation, which does have an electrical component. So they don't absorb or re-radiate thermal radiation. The greenhouse gases on the right have different elements and their electric bonds are not symmetrical. So they can be influenced by the electric field of the thermal radiation. So the greenhouse gases absorb radiation and they can also re-radiate it. And this is a thermal image of methane, which is, a powerful greenhouse gas. This is the Porter Ranch methane leak in the San Fernando Valley that occurred in 2017. So the chart on the left shows the carbon dioxide equivalent of the greenhouse gases that we emit in the United States in the atmosphere. The carbon dioxide is the main emitted greenhouse gas at 79.7%. Methane, the main component of natural gas, is 11.1%. Nitrous oxide, also known as laughing gas, comes in at 6.1%. Um, Interesting thing about nitrous oxide, it's used in whipping cream. So the nitrous oxide is absorbed by the fat of the whipping cream. And when you squirt it out, the gas, which was under pressure, then expands and it foams the whipping cream. And it foams it about twice as big as you could do by whipping it. Anyway, the nitrous oxide, 40% of it comes from emissions produced by the breakdown of nitrates used in fertilizers. And the chart on the right shows the emissions by sectors. Transportation is the largest emitting sector, and electric power, we should be able to reduce that to zero with renewables. Environmental concerns. Um, We're in the Anthropocene epoch or the age of man. So humans have been transitioning from hunting and gathering to farming and animal husbandry. People organized into cities and collectively they could build the infrastructure and social organizations so they could big projects that could be really big projects that could be realized. The availability of inexpensive fossil fuels was a big driver in the Industrial Revolution. But using coal, oil, and gas now generates carbon dioxide, which is causing us problems. This is an eye chart. No, this is a chart that is a result of all this productivity. Um, Historians call the age that we're in right now the Great Acceleration. And so this chart shows some of the different things that are occurring now and it's being accelerated by our technology, et cetera. So this chart is from what, 1750, and 1950 is labeled in red. I'll zoom in on some of them. So here's carbon dioxide. You can see the prehistoric levels were around 280 parts per million. Now we're up to 433 parts per million. Surface temperature is going up. I think we're up to 1.5 degrees. Ocean is being acidified. We're losing tropical forests. Domesticated land is taking over a lot of the land use, and we're losing some of the biosphere. So when considering climate change impacts, the disclaimer made regarding stocks comes to mind. That is, the past performance is no guarantee of future results. So that really needs to be taken to heart in this moment. Since the end of the Ice Age, our world has seen a very stable period of weather, but with the sudden changes brought on by humans, especially the sudden rise of carbon dioxide, it's hard to imagine what the future will look like. Will our ecosystem be able to keep up with the changes? So temperature is one of the main drivers for the environmental impacts that we see. This chart shows the temperature change from 1880. Might be noted that January 2025 was the warmest in the 176-year global record. Carbon dioxide and other greenhouse gases are causing the Earth to heat up. And carbon dioxide stays in the atmosphere for hundreds of years. So the one thing that I'd like you to take away from this presentation is that because carbon dioxide stays in the atmosphere for hundreds of years, what we do or don't do now will affect life and the environment for centuries. So we need to start reducing our impact on our world. So here's a list of environmental impacts that I came up with. I'm sure there are more. I'm sure you have some that you could add to it also. Extreme weather will cause lots of damage and destruction, and loss of life. Wildfires, drought, uh, and we're going to be losing biodiversity. Our ocean health is at risk. We're having to worry about sea level rise, food insecurity, climate migrants. I mean, we see that already. People from Africa and Central America are leaving because they can't make a living farming anymore. Health, we have heat and air pollution, and also we have insect vectors that are taking uh, diseases further north as the climate heats up. And there's huge financial impacts on the horizon that I don't think our leaders are really taking into account. And there are also large environmental and economic justice concerns. Uh, this chart shows the biomass of land animals. Just kind of interesting. 100,000 years ago, uh, we started losing some of the um, total land animal biomass. But in the 1850s, the total started to go up, and that's because of domesticating animals. And now in 2020, uh, the ratio of domestic to wild animals is huge, as you can see. Land use is a huge contributor to environmental impacts also. Traditional farming breaks up the soil, disrupts water retention, and disrupts healthy biomes in the soil, which sequester carbon. And dust can also be a problem. Just driving up the Central Valley, you can see this in action with many fallow fields. And around the world, land is being used for, in this case, this is a palm oil plantation. So they're knocking down some of the forests that have sequestered carbon for centuries and turning it into agricultural lands. And I've heard some people say that we don't alter our environment. Well, here's a picture of a machine that's used for strip coal mining in Germany. It's called the Bagger 288 excavator. I'll blow up, see that little circle off there? I'll blow it up and show you what that is. That's a that's a front dozer. So, I mean, that's a huge machine. The bagger weighs in at 29,800,000 pounds and it's 315 feet tall. And you can just see what it's done there. It actually destroyed a city in Germany. So our future, we have a choice in our future, and that's something that we need to take into consideration. What can we do? Well, we can mitigate and we can adapt. Mitigation is to reduce the cause of the environmental damage. Adaptation is to adjust to the changes that occur in our environment. Of course, one of the main drivers is carbon dioxide. So here's a chart of our carbon budget. On the left are the carbon sources. The main ones are coal, oil, and gas, and to a lesser extent, cement, and also land use. Some of the carbon sinks are cement carbonation, where the cement actually absorbs some of the carbon dioxide, and the land and the ocean. So let's take a closer look at how we can mitigate some of these things. So one thing we can do is just electrify everything we can, especially transportation. And you can, let's reduce vehicle miles, reduce waste, transition to a circular economy where things get recycled and not wasted, reduce food waste and keep organics out of landfills, reduce burning of fossil fuels, reduce methane leaks, use low impact refrigerants, employ sustainable farming, preserve forests and habitats, and the list goes on. Transportation accounted for 28% of greenhouse gases in 2022, and since then, we have definitely alternatives to fossil fuel transportation. So, we have active transportation, walking, biking, mass transportation, EVs, autonomous vehicles, and alternate fuels. So active transportation, let's get our cities walkable, have bike paths, and have car-free streets. And also, low-speed vehicles are another option too. And here are some low-speed vehicles. These can, since they're so small and most of them are running on electricity, um, they are limited to 25 miles per hour. They're allowed to drive on streets with speed limits posted up to 35 miles per hour in California. But I just want to show you this map of Peachtree, Georgia, that has extensive uh, paths that can be used for these low-speed vehicles, golf carts, bikes, and pedestrians. So in this city, residents can go from neighborhood to shopping centers, schools, and parks, uh, and by just using those means of transportation. And my brother lives in a small town where people drive around in these neighborhood vehicles. And I find that it's much more social because invariably, as you're driving around, you say hello or you strike up a conversation with your neighbors. And EVs offer certainly a way to reduce greenhouse gas emissions. This is a photo shot, aerial photo of last year's Ventura County EV showcase. It's held in the Ventura Harbor early in October. And of course, the advantages of EVs are they're cleaner, they have lower operating costs, mainly because your brakes last forever because of regenerative braking, and there's no oil changes. There's also reduced noise. The upfront cost historically has been higher, but I predict that it's going to be lower than uh, gas-powered vehicles shortly because they're much less complicated and have a lot fewer moving parts than gas cars. And here's a pretty comprehensive list of EVs from the evinfolist.com. They have all of this data, including, the towing capacity of the cars even, and, what the range is and the battery size, etc. So I find it's a really good resource and it's updated. I think it's updated monthly. So EVs can also be used for storage. And there are a lot of designators for that floating around. There's vehicle to grid, vehicle to load, vehicle to home, and vehicle to everything and everything in between. So basically, your car's battery can be used as a power source to supply, your home or a business or, remote workers, maybe on site at a construction site. And one nice thing about that is that you can power your home with it, and if there's an emergency and you don't have power, you can go charge up your car, come home, hook it up to your home, and keep the lights on. And EVs are the least expensive way to get storage in your home. This was a study done, and it does show that EVs are, the cheapest. What it would take would be to have an EV that is vehicle to grid ready or vehicle to home ready, and you need a special bidirectional charger. The chargers right now, I think, are about $2,000 or $3,000, but they should come down because they're not that complicated, and parts are certainly available. Diesel trucks can be replaced with EVs. I saw a program just recently where they drove a diesel truck across Australia, and they were saying how great it was because the diesel trucks have a lot of torque and they can take other trucks, they can leave trucks in the dust on hills and things. They have high torque and high horsepower. They're quieter. They have a lower cost of ownership because there's less maintenance, but right now there's a higher initial cost. And autonomous vehicles. Household vehicles right now spend 95% of their time parked. I think ours spend even more than that. So if autonomous vehicles catch on, there would be reduced parking space requirements, and it would offer a last mile solution for rapid transit. You get to a station and you could just call up a autonomous vehicle to take you home. And this was all written up in a book by Daniel Sperling called The Three Revolutions. He was talking about how this could really revolutionize transportation. Um, and of course, there's mass transit. I've been to Europe, and I really like the mass transit over there. It's too bad we didn't do that here when we had when we had a better chance of integrating it into our cities and between cities. So the other thing is to electrify everything. Electric systems are more efficient. They're 3 times plus more efficient than fossil fuel heating, and for transportation, for turning heat into for giving motion or transportation. And 95% of all fossil fuel systems can be converted to electric systems. And that was, I'll get to a book here in a second about that. And just to be a little nerdy here, this is the equation for efficiency. It shows how efficiency in turning heat into work, into motion. It depends on the exhaust temperature, or the high temperature is TH, minus the exit temperature, which is T cold, divided by the hot temperature. So basically, at 300 degrees Kelvin, which is basically room temperature, in order to get even 50% efficiency, you need to have your hot temperature working at 600 degrees Kelvin. So it's a pretty hard thing to do. And this is called, just to get real nerdy again here, this is called a Sankey chart, or energy flow chart. And what they do is they show all the energy sources and all the energy outputs. But the important thing, or the interesting thing to me, is just looking at the rejected energy. Now, this rejected energy is energy that is wasted. And you can see transportation here. Transportation wastes a lot of energy. The overall efficiency of the transportation sector is 23%. That can be up to 85% if we go all electric. And some of the industrial processes can be helped with electrification also. In heating, heat pumps are, like I said earlier, three to plus times more efficient energy-wise than just regular heaters. And these are some of the books that talk about the feasibility of that. One is Mark Z. Jacobson, who is from Stanford, and the other is Rethink X. Tony Seba is one of the principals there. And both of these people have been talking about how we can do electrification right now. And I'm a strong believer in distributed electrical systems. And this map shows the potential for supplying the states with just rooftop solar. So this California has the potential to supply more than 55% of its electrical energy needs, or electrical needs, by just using rooftop solar. And that really doesn't include things like covered parking lots and other large structures, or maybe having solar panels in your city somewhere. So as far as mitigation using carbon sinks, so the carbon sinks are mainly land and ocean. So to help mitigate and take carbon dioxide out of the air, we want to preserve vegetation, the forests. We want to take care of our soils, don't disturb them like we have been, and practice sustainable farming. In oceans, We want to encourage tidal marshes, mangroves, which protect the coasts as well as taking carbon dioxide out of the air, seagrass. And there's a movement called Blue Ocean, which I'll get to in a minute here. So this is an international organization called the International Blue Carbon Initiative, and it's a coordinated global plan focused on conserving and restoring coastal ecosystems for the climate, for biodiversity, and for human well-being. So this includes preserving tidal marshes, coastal mangroves, and seagrasses. And another program that's here in California is the Reef Fish Project, and they are building artificial reefs with materials that mimic natural reefs to attract and give homes to grow marine life. And recently, the San Fernando Valley Climate Reality Chapter featured the Fish Reef Project, and there is a video of that meeting that can be viewed on their YouTube channel if you're interested. And other things that are in concept. This is a proposed scheme that is artificial upwelling and downwelling. So the concept here is to bring cool, nutrient-rich deep water upwards to stimulate growth of plankton, which would capture CO2, and then later it would sink to the ocean floor. I would imagine this would also increase the fish populations too, because there'd be more, plankton for them to eat. So this is an experimental thing. It hasn't really been proven yet, so we'll have to see. Adaptation. The adaptation can be implemented fast, especially compared to mitigation. So, that includes, fireproofing buildings, improving infrastructure that can take some of these hits from the environment, the weather, and so on. Also, to retain soils and try to keep water supplies secure. And also extreme heat could be an issue. So, cooling centers can help with that. And we also have to be careful and be wary that the workers can be exposed now to high heat and have heat stroke. So those are some of the things we can do. And, we have done big things in the past. We've reduced smog with catalytic converters and taken lead out of gas, and we've banned CFCs so that we could preserve the ozone layer. We bailed out the banks in 2009. We've sent people to the moon. So we can do big things, but we need to start directing, I think, some of these big things to mitigating and adapting to our changing climate. So things that we can do as individuals, certainly advocate for climate change, call your representatives, speak at council meetings, write letters to the editor, and post on social media about the climate, talk about the climate to your neighbors and friends if the occasion comes up. Vote. Vote's a big one. And also reuse, reduce, repair, recycle, and whatever other permutations there are of that. Electrify what we can, reduce vehicle miles, consider the environment in your purchases. Diet, consider your diet's impact on the environment. And I'd like to highlight a few things that I think are interesting. This is one. This is a repair cafe. It's put on by the Community Environmental Council. And so far they've had 3 events with attendance of over 100 people at each event. So what they do is they help you repair clothing, small appliances, toys, electronics, bikes, furniture, what have you, uh, with skilled fixers guiding you through the repair process. So not only do you get to fix your items, you may even learn some skills on how to do it the next time. It's a hands-on event and you can take part, and they also offer light refreshments and entertainment. And they say community conversation while you wait. So anyway, I think this is a great idea. I hope we expand that into Ventura County and talk about the climate. I think that's peer-to-peer is probably one of the best ways of influencing people. And unfortunately, coverage of the climate is declining. I mean, this shows you what corporate broadcast TV news coverage has been decreasing. Uh, and so uh, I'll give you some tips that I've run across, some people that I think have some good tips on talking about the climate. Katharine Hayhoe is certainly one. She likes to find common ground to begin conversations about climate. Um, Stephen Lewandowski and John Cook address misinformation and as well as how to talk about climate change. Uh, Tali Sharot is a neuroscientist who has explored how we process information and what challenges there are in changing people's minds. David McRaney, he has a book that How Minds Change. In this book, he describes lessons that he learned from canvassing over 2,000 people for the California Same-Sex Marriage Initiative in the early 2000s. So some of the lessons he learned are pretty interesting and I think are worth uh, looking into. And Frank Luntz, I don't know if people have heard of Frank Luntz, but he was a speechwriter for the Republican Party. He came up with phrases like death panels when speaking about single payer health care. And although I don't agree with his politics, he does have some interesting techniques for engaging listeners. One of his, which is, what what do you imagine would a perfect or a good environment look like in the future? Imagine, bring your people into their imagination to get them actively thinking about a subject. So he had some good points. So this is a book, or it's actually available online, uh, the Debunking Book, and it's by Lewandowski and Cook. So it's a pretty good. Um, it's got pretty good prescriptions for addressing misinformation. And I'll just go over really quick some of the latest technologies for your home. And I think that we don't, as a whole, don't know that much about some of the interesting devices that are out there. And same goes for the contractors that can really help us electrify our homes. So here's Edison's schematic of what can get electrified in your home and electric appliances and things. The usual rooftop solar, battery storage, heat pump, air conditioning systems, washer and dryer, induction cooktop, lighting, heat pump water heater, electric vehicle, electric panel. So those are the things that are available to be electrified. Um, Storage batteries, they can really help reduce your costs and add reliability to uh, your home, especially keeping your food refrigerated. Um, and here are some power efficient appliances, and these can be plugged in to a regular 120 volt outlet. including, washer dryers, heat pump water heaters now. You can just plug them into a regular outlet. And there are some air conditioners, new air conditioners that are a lot better than, but a lot better looking than the old style. This particular one here, you just drill a few holes in an outside wall and set it there, and you're good to go. And here is a saddle mounted heat pump. And this is one that you could take to, renters could use, and then if they were leaving, they could take it with them. It is pretty slimline in the inside, and the outside is not much bigger than this on the outside either. So it's not too bad looking. And one guide that I will recommend is, this is actually from the Ask Sean show. It's Pocket Guide to All Electric Retrofits of a Single Family Home. And it just details all kinds of different appliances and things that are electrically driven. And just to go through some of the devices that can save you some money. If you have a 240 outlet and you need to have another outlet, you can get smart switches. So a smart switch, say, can be shared between an electric dryer and your car charger. So that's one way of not having to rewire your house. Meter collars is another concept. So there's a collar here that you just unplug your meter and you plug this meter collar in, plug your meter back in. Of course, Edison does that for you. But it will allow you to either plug in solar panels or hook up your electric vehicle without touching your electrical panel. So that can save you lots of money if you don't have any room in your breaker to put another breaker in. And of course, you can use your EV as storage. And there's also smart panels. So smart panels basically do what those switches do, but it does it for the whole house. So you can put priorities on different appliances in your house, and say you have an electric water heater and it's running, but you want to run your oven. It could automatically turn off your water heater so that you have more power to your, without drawing more power from the power company. And the power company would love that because that would flatten out their load, make it a lot better. They wouldn't have to respond to a lot of the peak power requirements. And a new concept that is, well, it's not new in Europe. Germany is very popular, balcony solar. And so far, Utah has already passed a law allowing the installation of these balcony solar panels. And California right now is working on a law. It's SB 868, and it's in the legislative process, and I think it will pass. So you'll be able to just plug in your solar panels right into an outlet, and that's it. You're done. You don't have to do anything with your breaker panel or anything, and you'll get some solar. Not a whole lot of solar. It's limited to, I believe it's 1.2 kilowatts, but it's something. So that's that resource again, and that is the end of the presentation. I just want to say that, we've really been gifted with this earth that we have. I mean, it's the more you think about it, the more amazing it is that it's supplying us with all of our needs, and it gives us joy just looking at some of the marvelous features that it has. And I'm just really lucky to be on the earth.
Wayne, we have lots of questions that have come in our chat. So if I can
Okay.
read some of them, we can start with this. What are the most important financial impacts you were talking about with climate change that our leaders are ignoring?
Ah, well, it's just going to be drought, drought, affecting farms. That's going to be a big one. We've already seen some drop in crop yields in the U.S. Um, but also, floods, and farmers have also had flooding. And flooding really does a lot of damage to the infrastructure. And so, with flooding, and then of course there's wildfires. So with all of these forces, affecting our infrastructure like that, we're going to have a hard time financing all the rebuilding of these things. And what do people do, like, that are in floodplains right now? They're at the point where they can't insure their homes, so they can't sell them, so they're kind of stuck. I mean, it's really a difficult situation. So, there's some really large economic justice issues on the horizon. And yeah, and unfortunately, the financial people seem to think that because this damage is happening out in the future, they can discount the cost of it. They can say, "Oh, well, we'll have more, we'll have more things to cover the cost of it." But I think that's a bogus argument. You can't discount it because the resources are going to be used up more, and the value of money in the future is going to go up also. So I don't know how they get there, but with that reasoning. But yeah, I think uh, I've heard some estimates of maybe hits to the economy of 20% by 2050, and that's huge. That is huge. And
Along
yeah,
along those lines, Cleve Law says one of the things that disappoints him is seeing the Palisades and Eden Fire homes being rebuilt using standard wood stick frame construction and instead of
yeah, I don't know. Uh, there are techniques with wood frame construction to harden your homes. I don't think just because they're wood frame they're necessarily not, hardened. Um, so there are techniques that um, are probably more resilient than just wood, but um, there are a lot of the biggest thing is the embers. If the embers get in your attic, you're toast. So that's one of the biggest things that we have to worry about. And so I would encourage everyone, if you haven't got put fine screen mesh in your vents, in your attic vents, do that immediately. That's the best thing you can do.
um, Susan Seitz asks, what do you know about sea creatures very deep down in the Arctic that eat up carbon dioxide?
I'm sorry, what was that question again?
It's what do you know about sea creatures very deep down in the Arctic which eat up carbon dioxide?
I don't know much about those. Yeah, I can't really comment on that, but I know there are a lot of creatures down there, and that's one of the concerns that people have, environmentalists especially have, about this deep sea mining for like manganese nodules and things. They're really concerned about upsetting the deep floor ecosystem. Now, there are a lot of hydrates, uh, carbon dioxide hydrates in the bottom of the ocean floor. And as the ocean warms up, there's a concern that some of the carbon dioxide is going to be released. So, yeah, but I'm not an expert on deep sea creatures. Sorry. If they were electric eels, maybe, but
Can you talk about AI in the the whole impact that we're seeing with computer storage and memory in these data centers, that I feel like no matter all the progress we're making with other stuff, the rabbit is so much faster than us turtles.
Yeah, that is a big concern. Um, does require huge amounts of electricity, and it's got to be there, 24/7. So a lot of these AI companies are building their own power sources right on site, gas-fired turbines. And unfortunately, where they locate these, if it's near residences, all of this exhaust from these turbines and the noise from these turbines is going to really, affect their environment. So, yeah, there's so much money being dumped into AI right now, and so it's like the gold rush, and so everybody's hopping on, and so they're saying, oh, we need more and more electric power to power these things. So it my concern is that big demand is going to be spread across us, the non-industrial users, and that's really going to inhibit a lot of progress, I think, in electrifying. And just the fact that they're using gas turbines is not a good thing either. So, yeah.
So I'm going to focus on some electrification questions here. Cleve was saying he was disappointed to find that his homes with PV, I think that's photovoltaic solar, and the whole house batteries cannot accept V2G equipment as it's currently designed. Can you speak about that?
Well, yeah, vehicle to grid is still in its infancy right now. So, integrating that into existing systems could be an issue. Um, so we'll just have to see how it plays out. I mean, it's a lot of the vehicle manufacturers right now are, um, going that route. They're making systems compatible with vehicle to grid. Uh, I believe, I, I think that by 2027, California is going to require all the vehicles over a certain battery size to be capable of vehicle to grid. Uh, but on the other end, yeah, there's going to be electronics eventually that will handle it. And a lot of it is software, just compatibility. But those standards are in place now. So I expect that um, they should be able to integrate with some devices as they become more available. There are only a few manufacturers right now of these bidirectional chargers that you need to do that. So, well, the future will change, though, I'm sure.
Uh, Another point Cleve made was one piece of disinformation that he hears is that the US produces less total carbon than countries like India and China. However, per capita, each person in the US produces an order of magnitude or more carbon than those in India and China. So we have the greatest opportunity to figure out how to reduce carbon production. Cleve, do you want to say anything about that?
Yeah, I mean, I run across a lot of people. So, well, just real quick in terms of background, we live in Long Beach, but we built this house specifically to be as environmentally friendly as possible and recycled products in the construction, solar, all electric house, etc. And some of my friends who are climate naysayers are like, well, India and China, they just produce so much more carbon than the United States. And as a pure number, yeah, but when you look at the per capita production of carbon, again, it's at least an order of magnitude, if not more. And so, we can do a lot more on an individual level, if you will, to bring it down.
Yeah, I think the actual number is more like I think the Chinese per capita is more like 75% of what the US is. But yeah, just because of the population difference, I mean, they are emitting more. But historically, I think cumulatively, the US probably still has the most carbon emissions, has generated the most carbon emissions that are out there. The other thing that I should point out is that China really has a plan to go to renewables as fast as they can. By 2050, I think they're gonna be there. And I mean, they are putting up solar panels like crazy. I mean, they put up more solar panels in a day than we probably do in 6 months. It's just amazing how quickly they're moving. And the U.S. is by being reticent or denying this carbon dioxide effect and all of that in the future, we're really allowing China to take the lead in a lot of these industries that we really invented. So, I mean, it's really a shame, I think, that this is happening. Uh, we need to regain uh, our our vision. I think that's one thing as a society we are lacking. I mean, what kind of future do we want? I think we should be asking that. Ideally, what would we want? Um, we want to have trucks running around that make all kinds of noise and blast out carbon. That wouldn't be in my ideal world. So I think as a society, we need to kind of figure that out and coalesce on an idea and a direction to implement that. But it's not happening now. So, but the good news is the economics of electrification are winning. I mean, solar panels are the cheapest energy, and it's also the quickest to install. So, why put in another system? And the batteries, there's so much money going into batteries. Batteries is kind of the gold rush in the electrification side. There's so much money going into battery technology. We're going to see some really, really advanced battery systems that are a lot less expensive. So, ideally, every home could have a battery so that we could distribute the load and be kind of independent if we have an issue. So that would be one of my visions for the future is to be more distributed, um, less reliant on noisy things, and mass transit too.
I'll
Yeah.
I'll throw in one. Um, what what do you say about nuclear?
Oh, nuclear, yeah, that's a big iffy one with me. I'm for keeping nuclear plants open that are safe. I'm a little bit um, I think some of the hype about like small modular reactors, SMRs, I think there's a little bit of hype around that. Um, some companies have gone under. I think it's still more expensive than solar. Well, it's a lot more expensive than solar. So, and there are also problems with just security and the waste also. But I mean, I can see the need for having a constant supply that would certainly do it. So I I would try to solve problems without going to small nuclear or nuclear facilities. Geothermal is a good possibility for firm energy. Firm energy is energy that's available all the time, as opposed to intermittent like wind and solar. But geothermal, like the Salton Sea has a geothermal plant, and Clean Power Alliance is actually getting some of their power from it. But it would also employ drilling technology that we already have in the oil industry. So we could supply we could supply energy and keep some of the jobs from the oil industry. So that may be a win-win.
I'm wondering if Frances Lee wants to come on camera and ask some questions. She's been posting some comments. Please unmute, Frances.
Sorry about that. It took me a while to get my finger on it. I'm just listening to Wayne and just applauding and putting in my 2 bits as he's talking. And I just want to, spread what I know and what I've read. And those are the comments I'm putting in the chat.
Okay. Well, thank you, Fran. And thanks for all that you're doing.
Yeah, thank you. Yeah, I feel good about celebrating Earth Day this year. That I heightened enthusiasm. And I'll take that to my tabling.
Oh, good.
Thank you.
Yeah.
So some of the comments Frances had put into the chat is that carbon's being sequestered by dead animals. Gas turbines are currently in short supply, so it takes longer to build a gas plant than a solar or wind farm, which is good for renewables. Today, renewables generated more power than gas for the first time over the course of March. And she also mentioned that Finland is dealing with nuclear waste. It's huge and dangerous if anyone targets it.
Yeah. But anytime you have a centralized system, you're a little more vulnerable. So we have to be careful. I do want to mention one more thing too, and that is about sequestering carbon. Basalt rock, as it weathers, absorbs carbon dioxide. And in the past, there was a dip in the Earth's temperature, and they think it was because the Himalayas were forming, and that formation took a lot of the carbon dioxide out of the atmosphere. So one of the proposals is to grind up basalt rock and spread it on agricultural lands. I don't think it would do any harm to the crops. So that's an interesting concept. The other one would be to seed that in the ocean, and I'm not so sure about that one. But we do have to be careful whenever we take on these large-scale projects, because there may be some unintended consequences that go along with it. And if we don't find out about it early on, it could lead to more problems. So we have to be careful with what we do.
Along those lines, I was wondering about water desalination.
Oh, yeah, I think there's a lot of technology now that is a lot more efficient than the old technology, and so I think that has a lot of possibilities. So
we could crush up that salt and send it somewhere else.
Oops, you're muted. You're muted, Pam.
Michael has a question. Let's bring her on camera. If you can unmute, Michael.
There. Okay. I put in the comments 2 things about residential solar siting. When you're in all of the Eaton and Palisades fire, if the homes were required to solar site themselves in their reconstruction, I've had personal experience with it making dramatic differences. in the consumption to begin with. So you're not having to produce electricity to heat and cool your house. Your house is doing the job. Natives did it for thousands of years just by siting your house and controlling your window coverings. You can change the temperature in your house dramatically. That was one point that I want broadcast more, because it doesn't cost anything except design thought.
Right.
And
If I could just interject here, there is a movement, passive houses.
yes,
Yes, passive houses. Yeah, they so what the design of a passive house takes into account of the siting, like you say, the shading, etc. And you actually design the house for that site. And they design it such that the insulation is very robust. And one of the requirements is that the temperature difference in the house, I think, is like 1.5 degrees difference, no matter where you go in the house. And that's because the insulation is so good that you can achieve that. So that
but the insulation is a construction theme, the actual siding, so that you don't need to produce electricity to obtain that temperature is one of the points. And yes, the passive houses book and grouping have been around since the 70s, said this old lady. But the other point that I was really excited about is I saw a video on a semi trailer truck, a big semi haul that has a 750-mile range, which is a game changer in the trucking industry. And it is in production now at a test level. And the curious thing is, you drive it from the middle of the vehicle. You don't have a left or right seat, it is being produced by Elon. It's a Tesla vehicle, but the video I saw and the truckers that tested it were blown away by how phenomenal it is. So that could be online right now. It's terribly expensive, but the market could be manipulated if people wanted to manipulate the market.
very good.
So, and thank you so much for your presentation. It was wonderful.
Well, thank you. Oh,
Wayne, if you want, why don't we take one more question if we have it, and then we'll wrap up. Thank you very much. Are there any
and
final
by the way,
thoughts?
I will have the presentation available, and the presentation does have a lot of links in it. So I try to document the presentation as I write it. So yeah, so that will be available, and I'll have some other resources also available. And I do encourage people to, if you're interested in electrifying your house, check out the Ask Sean show. You can register at the Orange County Climate Reality Project chapter. So that's Climate Reality Orange County YouTube. No, not YouTube, just their regular website. So anyway, shameless plug. Sorry.
Well, we're happy to shamelessly plug your plugs in our handout that we'll send out.
Yeah.
Thank you so much for being here. And our audience, thank you so much for your great questions. Wayne shared so much good information today.